has learned? Has it learned the concept of object rotation? Does additional text help with object recognition? We need a methodology and platform for conducting such tests. In this paper, we present a novel visual analytics tool that enables hypothesis-based evaluation of machine learned models.
We propose a new semi-automatic method that uses topological features to guide users in tracing neurons, and integrate this method within a virtual reality framework. We use the Morse-Mel complex to find a set of candidate neuron arcs. The candidate arcs are integrated into a VR neuron tracing system and exposed through our Morse-Mel complex guided semi-automatic tracing tool. The topological ridge graph underlying our MSC guided tool is robust against gaps in the signal.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
Visualizing class separations is used in applications such as classification and clustering. However, many dimension reduction techniques are limited due to the issues of separability and interpretability. We propose a visual analytics framework to support the exploration of nonlinear complex separation structures with the power of locally linear separations.
Pixel Clipper allows visitors to quickly and expressively extract visual clippings from visualizations and add comments to them. The clippings are useful for engaging the public with complex datasets because they are entry points into the visualization. This can be applied in a wide range of engagement experiences, such as the use of facilitated and ambient displays at public engagement events.
Confusion flow is an interactive visualization for the performance analysis of classification models. It introduces a novel temporal adaptation of the confusion matrix, which lets model developers compare the learning behavior of multiple classifiers over time. Find out more about confusion flow in our talk or in our TVCG paper.
Suppose you want to see the overall structure of a new project repository. Using Git class tools, GitHub Network, or Git log command, it's quite burdensome to get overview and navigate data. We presented Gitthrough as an interactive visual analytics system for the Git metadata to help users explore and understand the context of development history.
The classifier trained on the historical data may fail to classify the incoming data when the data distribution is changing. This phenomenon is called concept drift. To handle the concept drift, we developed the Drift VIS, a visual analytics system to help the expert understand when, where, and why the drift happens, and update the model to improve performance.
With the proliferation of AutoML systems, it's now easier than ever for non-experts to create and deploy end-to-end machine learning pipelines. These systems explore the model search space and optimize hyperparameters in order to solve a particular task. We propose Pipeline Profiler, a tool that enables the exploration and comparison of machine learning pipelines produced by multiple AutoML systems. By analyzing these pipelines, we have the opportunity to better understand how AutoML systems work and obtain insights that can be used to improve them.
We propose an interactive ensemble analysis framework that provides flexible interactive exploration of the ensemble data. Time series characteristics of data can be obtained by fast browsing time steps. The region stability heat map view shows the stability of the selected region and provides region adjustment by directly clicking.
CMED is a visual analytics framework for exploring medical image data annotations acquired from crowdsourcing. CMED can be used to visualize, classify, and filter crowdsourced clinical data based on a number of different metrics such as detection rate, logged events, and clustering of the annotations. CMED provides several interactive linked visualization components to analyze the crowd annotation results for a particular video and the associated workers.
How many clusters can you see in these images? With different visual encodings in scatter plots, our perception of cluster count changes. We developed models that consider how visual density influences cluster perception. Further, we demonstrate using a threshold plot to optimize the saliency of clusters.
In our paper, we address the problem of navigating complex multiscale and dense environments, such as these molecular models. We present a technique for browsing a model by clicking on textual labels, which we call hyperlabels. This allows the user to intuitively navigate the hierarchical organization of the model. For more details, read our paper or watch the talk.
While meetings are an essential part of everyday business life, most calendar visualizations are not designed for retrospection. We present a tool consisting of 4 coordinated views that integrate into the user's daily workflow and are designed to promote self-awareness about past scheduling decisions. We discuss the insights gained from an internal user study and from a field deployment. We also discuss how we strongly inherit from the principles of personal visual analytics despite targeting a professional environment.
Hands-on cybersecurity training represents a domain where visual analytics can significantly improve the impact of teaching process. We describe this new application domain and introduce a conceptual model that can serve as a framework for the development of analytical visualizations. Unified training lifecycle will be discussed from the perspective of different user roles.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.
Text alignment is a fundamental technique in many text-related domains. In this survey, we cover 3 text alignment scenarios: collation task, text reuse detection, and translation alignment. On the basis of those scenarios, we reviewed the existing text alignment visualization approaches and discussed their advantages and drawbacks. We finally derived design implications and shed light on related future challenges.
We demonstrate that people can use the spatial cues available in virtual reality to help them effectively remember and recall scholarly articles. We used a virtual coffee shop and asked participants to remember 4 abstracts from scientific publications, and we termed this method a virtual reality memory palace variety.
When developing a deep learning model, people typically struggle to optimize hyperparameters that affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. Hypertender helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about.
Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Out-of-distribution samples refer to the test samples not well covered by the training data, like these black cats. They are misclassified with high confidence due to their black bodies. To explain why these samples are out of distribution, we developed OOD Analyzer, a visual analytics tool which provides an ensemble detection method and a grid-based visualization to detect and analyze out-of-distribution samples.
In our current work, we visually compare two cohorts of segmented and classified tissue images, originated from single-cell omics data. To that end, we developed data-driven and interactive workflow implemented in a multi-linked view system. Finally, we show the effectiveness of our workflow through specific case studies.
Attention mechanisms have greatly improved the performance of many language models, yet with great power comes increased complexity. In this work, we present attention flows, a visualization that let users interpret the language model's decisions and gain insights into the underlying self-attention mechanism. We also support model comparison that helps to fill the gaps between models in different training stages.
Deep neural networks are vulnerable to maliciously generated adversarial examples. This brings high risk in applying these networks to safety-critical applications. We developed a visual analytics approach to explain the root cause of such wrong predictions. Our contribution contains a constrained path extraction method, a river-based visualization, and a contribution analysis method.
Data videos are quite popular nowadays. They usually show changes in the data. However, creating a data video requires multiple skills, and the process is usually laborious and iterative. Our approach focuses on automatic and interactive visual enhancement of important changes in time series data with data video.
Syringe graphs are variants of stack graphs with curve-based line, and the main factor affecting its readability is the sign allurance through a perceptual inconsistency of the orthogonal and vertical direction. Aiming at reducing its impacts, we revisited the baseline formulation and proposed the concept of composition to help the syringe graph layout optimization. The result shows that our algorithms perform better than the others.
Hi, everyone. Welcome back to session 3 for BELIV. This is our provocation section, which I'm sure is going to be super exciting. My name is Miriah Meyer, and I'm joining you from cold and snowy Salt Lake City, which is kind of perfect for our very first portion of the section, which is going to be a fireside chat with Michael Correll and Tamara Munzner. The fireside chat is based off of Michael's BELIV paper, which was entitled, "What do we actually learn from evaluations in the heroic era of visualization?" Which we, the BELIV organizers, read and felt was an incredibly provocative paper that we thought there would be no one better in the world to speak to it than Tamara Munzner. So what we're going to do during this fireside chat for the first half hour is we're going to get to hear from both Michael and Tamara on their ideas of evaluation and applied visualization research and design study. And so for those of you who don't know our two panelists here, Michael is a research scientist at Tableau Software, and Tamara is a professor at the University of British Columbia. So to start, Michael, I pass things over to you to give us an overview of the position that you laid out in your paper. You're muted. Unmute.
There we go. Yes, thank you for the introduction, Miriah. So, as mentioned, I'm going to ask what I think is an extremely loaded question. What do we actually learn from evaluations in the heroic era of visualization? So emphasis here is that this is a provocation paper. So I wrote this paper in sort of the true Socratic tradition, by which I mean not necessarily logic and reason, but more being deeply annoying until the public authorities forced me to drink poison. And what kind of motivated this paper, or sort of some pet peeves as I read Viz papers or even write Viz papers, right? There's a feeling, and this has been called in fiction writing, Dorothy Jones Hyatt calls it the 8 deadly words, which is, I don't care what happens to these people. What I mean is that I'll read a paper where someone went out into the world and they built a bespoke visualization tool with a very specific set of domain collaborators. And I'll read it and I'll think it's nice that the authors helped people. And I think it's nice that the authors got to build these important skill sets when they made their tool, but I don't necessarily know why I'm hearing about it. And at the end, I often am not convinced what I got out of that paper.
Hey, Michael, really quick,
yes.
I think you had some slides you wanted to share as well.
Yes. There we go. How does this look? Better? Better Perfect. Or worse? Great. Right. Yeah. And so there's a simile, which is that when I go through these papers, and when I'm writing my own tools about my own papers about the Viz tools that I made, is that the whole thing is kind of like a ship graveyard. There are these huge, complex, expensive engineering projects that are left to rot by the dozens, abandoned and unused. And very occasionally, someone will brave the toxic conditions and strip the thing for spare parts. I'm not really certain what the equivalent is to reviewer 2 rejecting your paper because they didn't break apart their personal rusting ship, but that's kind of a component as well. So from this simile, I move to a metaphor, which will get increasingly tortured over the course of the talk. And I think it's part of our self-conception as a field. And I kind of wonder if we're in what I call visualization's heroic age. So here I'm drawing a comparison to the heroic era of medicine, which is a sort of period of medical practice in the West, starting around the middle of the 18th century and ending about a century after. So this is individual doctors who would just wade into battles and epidemics, and they would bleed and purge their patients over and over again until they got better, or more likely died. So one of the key figures in the heroic era is this guy, Benjamin Rush. That's him in the painting waving the sword around behind George Washington. And he's on his way to treat General Mercer, who's the fellow trapped with the dead horse. Rush gave him a ton of mercury-based medicine and tried frequent bloodletting, and the general died 9 days later, but Rush said it was because he had concussion due to a musket ball. So this is what I mean by sort of this heroic era of medicine, people going in, and I really do mean sort of heroic actions, right? Benjamin Rush is also famous for going into Philadelphia during the yellow fever outbreak of 1793 And he got some things right and some things wrong, right? While other nurses were fleeing the city, he was proposing things like contact tracing and quarantine. He did think that the entire epidemic was caused by some damaged coffee, which putrefied, which wasn't exactly right, and did things like explode barrels of gunpowder to try to increase the amount of oxygen, but his heart is in the right place. So there's these kind of things that are hallmarks of heroic medicine, right? Individual heroic actions, these extreme interventions, and at the end, poor theory. And what I really mean by that is poor correctives for theory. Like the theory in this case they had was that of humorism, which had been around for many years, but they didn't have necessarily the tools to examine it. So that's what I mean by heroic visualization, sort of a parallel to this heroic medicine. It's the same kind of heroic action that I see in places like Philadelphia. There's an individual jumping in to use their unique expertise to solve a pressing problem. And it kind of works, right? But we don't necessarily have enough theory in the same way we might not have had enough theory in medicine. So there's some problems with this particular action of just going in, working with a domain expert, designing a system, and then doing an evaluation and writing it up. I'm kind of loosey-goosey with the terminology in the paper, which is, I think, one of the reasons why Tamara is going to be so mad with me in about 5 minutes or so. But I really mean, instead of a design study paper, what I kind of mean is a colon paper, right? By which I mean there's an acronym or some other proper noun, colon, and then it's a visualization system for solving a particular problem. So I often don't get a lot of things out of these colon papers. And I think there are some problems with the papers that they're conceived that kind of mirror what I mean by the heroic age of medicine. So the first is that we choose, I think, very small problems or idiosyncratic problems. No one was able to help them until we jumped in. This might not be because we're particularly brilliant, but it might just be nobody else has their particular hyper-specific need. Right? There's a saying in medicine, if you hear hoofbeats, think horses, not zebras. I think we focus a lot on zebra problems. Right? And then there's this second issue, which is that we don't often compare against placebos. Right? Once a problem is kind of considered interesting enough to pass the first stage, the default seems to be to engineer a big system from scratch. Right? We compare against other solutions or mention them, for instance, in our related works, but I very infrequently see a VIS paper where they admit that an existing solution was better. I think there's some perverse incentives at play here that mean we wouldn't necessarily use a placebo even if we had one. And then there's this last issue, which is that, right, and this is a sentence I use a lot in the paper, a doctor doesn't get a paper in a top tier medical journal every time they cure a patient or every time the patient doesn't die. And yet what we've done is built a system where sort of the main way to get points is to follow what I think is a pretty standard design procedure and then write it up for a conference. And I just kind of feel that there's some sort of diminishing intellectual returns for producing hundreds of bespoke systems a year. So that's unfortunately the end of my time. I think there's some styles of fixes that can move us out of the heroic age. So the one is making things more comparable across time, make them sort of more useful, right? You know, if we're supposed to sift through all of these colon papers and get the useful bits out of them, that means we should be using the same language, we should be using open data and open code, and making sure that the papers can talk to each other. The other one is giving professional incentives for design work other than conference papers, right? In other design fields, you don't write a paper every time you design something, but you do have things like portfolios. And then this last and this one I'm most jazzed about is theory-driven design, right? Which is instead of following roughly the same procedure as everyone else, what if we set out to, for instance, say, build an explicitly feminist or an explicitly anti-Tufteist design or system, and then analyze it through that lens, right? Then at least we have some theory we're working forward and we can learn things from it. Okay, so that's the end of my time. If you're interested in more details, I've got a bit.ly link, just go to Heroic Viz, and I'm sure we will talk more after this.
All right, so I was tasked with being provocative, as was Michael, so I will do that. So, provocations. Also, what is happening with my, something has gone wrong because my slides are supposed to be building. That's not what I appear to have. I'm going to do something different. Very briefly, I'm going to stop sharing and I'm going to just do a full-on play, and that perhaps will work better. And now I will try sharing my entire screen. Let's see if that actually does a proper build. Aha, okay, I have the slides of my dreams. So I do agree with Michael on something. We totally agree that applied VIS research, and what I'll think of as design studies, really are N=1 case studies. So we have a point of agreement. And what do I disagree with him about? Pretty much everything else, but not absolutely everything. But a lot of the implications of that framing, like I really disagree with this idea that case studies are near useless anecdata, and many other things, both methodological and rhetorical. And I'll walk through a few of them now. So metaphors matter, and so I'm going to introduce a counter metaphor. So I think of VIS researchers as biologists, and in a design study, then that's a field biologist. And so collaborators, not patients, but a specific group of animals. A mob of meerkats is going to be my running example, in part because they're cute. And in this metaphor, a domain is like a species, and a task abstraction is like some abstraction of animal behavior, and the analysis process is the context in which these beasties live. So continuing with this metaphor, does a case study merit a paper? You know, there was the Lancet question, but I ask, should a biologist publish every time they observe animal behavior? And by and large, the answer is yeah, that's actually what they do. They go into the field and, you know, they study the meerkats for a few months, they come back, you know, analyze their notes, think about how this affects biological theory. So if and only if they learn something new to biology, they do, and that is the common case. So it's not a weird case. And then this other sort of related question, do we need only one case study per domain? You know, should a biologist publish only if they actually identify a new species? And my answer is no, not at all. It's great if you've got an existence proof of a new species. If you identify one, that's really cool, but that's not the common biology paper. It's much more common that what we're trying to do is, say, document and analyze the existence of meerkat behaviors in contexts. You know, how does this group of meerkats act in the summer, in the desert, in the presence of coyotes, right? That's the question we can answer from studying this N=1 group. Continuing with that metaphor, so are abstractions for tasks and data useful? Michael is skeptical. He says we should avoid the idiosyncratic and often impenetrable task analyses that generate the N=1 paper experimental conditions for our work. I think they're totally useful. You exactly need them to transfer between these contexts. And if you avoid them, you've pretty much eviscerated the poor design study paper. So you miss the point if you skip that section. It's central. So in this metaphor, what could we learn from that N=1 single mob of meerkats? What are the behaviors? How does the context affect them? So, you know, do they act differently in the desert than in the field, in the summer than in the winter? Are meerkats different for badgers or similar to shrews? So we can develop theories that might transfer beyond the very specific setting of this one group of meerkats in June in this one desert. You know, what we want to say is, what matters? Does seasonality matter? Does terrain matter? Does body size matter? So we're trying to abstract from the specific up to something that has some sense of transferring across to other contexts beyond the ones that we actually laid our own eyes on. Now, so that's a metaphor thing. Let me also talk about a rhetorical technique thing. The big word for it is the Mott and Bailey fallacy. I like calling it the bait and switch shenanigans. And there's this technique of taking two positions that seem similar on the surface, but so there's this modest, easy to defend thing, the Mott. It's the castle on the hill with the big wall. And then there's this much more controversial thing, the Bailey, the village with, very easy to overrun from the barbarian invading hordes. And the issue is what you do is you start out with the controversial position, but then when somebody calls you on it, you're like, no, I meant that modest thing, the easy to defend thing. And I argue that that's actually what's going on, specifically here with qualitative versus quantitative methods, which is why I think this actually fits into the question of BELIV. So early in the paper, there's this claim that, design study evaluations do not suffice. And then at some point, there's this Bailey style thing of, well, quantitative studies occur. Oh, I switched my Mott and my Bailey. It was a late night last night. Sorry, my Mott and my Bailey are switched. They're switched. So the Bailey was the earlier design claim that design study evaluations do not suffice. And then the Mott is saying quantitative studies still occur in only a minority of VIS papers. But the thing is, design studies are almost all evaluated with qualitative methods. So how is that relevant to the question at hand? So that's that kind of shifting rhetorical ground that makes for some great sweeping statements, but it's really hard to back up. So in general, I think there was a lot of places where there was this whole sort of qual-quant issue. Michael argues existence proofs are small contributions. I don't think so. I think they can require dramatic theoretical shifts. Like, let's say you see a meerkat do a backflip. What if there was a previous theory that it was anatomically impossible, and now you have just disproved blah blah's theory about their anatomy? That's great. That could be big. I also have an issue with the setup for Michael's multiverse thought experiment, although I think thought experiments are good and multiverses are cool. But this premise that they cure cancer and they say thank you in their Nobel Prize speech to you, and then you get the study email and you're on tenterhooks because you don't know, your favorite eval method, whether quant or qual or insight-based, whatever floats your boat, you're going to find out the results of the study now. But that setup is not agnostic to your evaluation method. There should be no surprises in that email if you actually did a qualitative field study where you've been deploying it long-term. All along, you've been seeing how they've responded. You've been iteratively refining it to actually be better. So there's no shocks there. So that whole premise doesn't really work. And also, why would they have thanked you in their Nobel Prize speech if your system was complete crap? So that really does rule out like half the scenarios. A key thing, and this gets back to methods, if you deploy in the field, they can vote with their feet by walking away. They don't have to use it. They're not trapped in your lab with you in a stopwatch where you've locked the door for the next 45 minutes. So methods do matter. This whole thing about qualitative and quantitative and mixed methods, I think a lot of us know the methodology matters circumflex from McGrath. And so methods are really crucial. I do want to put in a plug for the paper from last time's BELIV, where it really goes deep into what can you do with these various methods, because we can't treat them in a completely unified way. The methods really do matter. And with that, I'll stop sharing.
Awesome. Okay, so Michael, was there anything in that you wanted to respond to?
Yes, absolutely. So first is that Tamara said she was adding more visual content to her slides, and I noticed that there was a thing about meerkats doing a backflip, and there was no animated GIF of a meerkat doing a backflip. So that's.
I hang my head in shame. I failed. Yeah.
So right. I do want to push back on a few bits. So the first one is the meerkat analogy. I think we both agree that the n equals 1, a design study is about a group of meerkats, hopefully not literally, depending on what your collaborators are like, right? But there's a, when I see a paper, right, I would expect, if I'm following the process lined out in the stacks and trenches paper, and I encounter a pitfall, my options are to bail out, which is sometimes a really good option, or my option is to write about why I bailed out. And that's actually part of the things that I find really useful about, everything you've written for, as long as I've been in the field, right? Is that it talks about the things that bail out. Like, I find that useful. And yet what I see is these colon papers where something that looks like it should have been a pitfall happened, but they just keep pressing on. And I don't hear about failures, right? Like I should really, I think in a lot of cases, something like Excel or an existing system is the right tool, or at least a right tool for solving their questions. And I should really, I expect to see papers in VIS where we were going to make this system and we didn't, and here's why we didn't. I don't see papers about not building things. And that's where I think the meerkat analogy falls down a little bit, because, and I had to look out what meerkat's natural predators were for this, right? But it's maybe less naturalists and more hyenas circling the meerkats, because most of us are trained as engineers. And so we have a hammer that's building a thing. And so we're going to be looking for nails in that meerkat. Okay, that didn't work out, that particular analogy, right? But we have this hammer, we're looking for nails, and we're rewarded for making tools, regardless of whether they need the tools or not. And so, right,
let me build off of that. Let me build off of what you were saying, Michael, and pose a question to you, Tamara. So Michael argues in his paper that there's a lack of strong theoretical underpinnings for conducting applied visualization type of research, and that what we do have focuses on the how of designing the tools as opposed to the knowledge that we gain. So I'm curious, what do you think needs to happen for the community to develop more theoretical knowledge from design study research?
I think there's a couple answers to that question. And so, and one, it's sort of useful to acknowledge that I think, Michael might start from the point of view of some of the worst possible design studies. And I think I start from the point of view of some of the best possible design studies that do absolutely everything right and follow all theoretical guidance, blah, blah, blah. And so maybe the interesting territory could be somewhere in between, because I tend to be like, but we said to do blah, blah, like in design study papers and these sort of how-to papers. So I think there is this gray area of people, doing the common thing rather than the absolutely best optimal thing in the universe. But so then my answer to that is, okay, so how about you follow best practices? And then but I think there's this deeper question, which is, how do you go from, I did this bunch of work with my collaborators to, we as a field know something that we actually care about, even if we don't care about these meerkats. I'm not studying meerkats, I'm studying tigers. They're carnivores, for God's sake. What could matter to me? And and in my analogy, it actually matters that they're both mammals, so there is something in common, and we might find some behaviors that actually are similar, even as there's things that are different. And so the way I think of it is that it really is crucial to make practice is interesting and important. And to go from practice to research, you do have to reflect, and you do need to think about, well, what are the guidelines? And this is where I get back to this idea that in order to get a research paper out of a design study, you do need to reflect about what you learned to either, propose new guidelines or refute old ones or refine them. I do think that's absolutely crucial. And so that's how you can go from these specific things to a more general thing. But I think there's a deeper question than that. And Michael's paper really made me sit down and think about it. And, you basically say it's an extreme thing to build something and stop it with the building already, calm down, stop building and think. And I think it's an interesting point that the way I see design is that you have to fundamentally build to learn. And we argue in the design study methodology paper, there's this big trade-off space and you can't optimize, you have to suffice. And theory alone is not enough. I think that you have to build in order to advance the theory. And then I thought, why do I think that? When did I start thinking that? And I dug up this book that I hadn't actually read since the 80s, Herbert Simon, The Sciences of the Artificial. And okay, because I'm like, let's go to someone, he's the only person, he's the guy who invented the word satisficing, he has a Nobel Prize and a Turing Award. I think the only person in the universe who has both. But I realized it was from this book that I really started thinking about this idea that engineering is fundamentally an instance of design, and that this idea of, what does he mean by the sciences of the artificial? This idea that there's a science of design, that you have to make artifacts that have properties and you have to learn how to design. And so there's this key thing where in the natural world you can observe, and in the artificial world you have to build. in order to observe and in order to figure out how to build. So there is this virtuous cycle of building and learning and building and learning. But part of it's because if you want to observe people using a system, there needs to be a system. Now, Michael's point is, yeah, but does it need to be a new system? Did you need to build a new system as opposed to maybe observing an existing system? And I think that's where it gets to the really interesting and nuanced point about, can you learn how to build without building? I think you can't. Can we observe without always building our own? I think we can. And that's, I think, where we hit the limits of my glorious meerkat metaphor, because then, this would be like the naturalists don't just observe the meerkats with binoculars, but then they start interacting with them and they offer them sticks and they see what happens. So, the analogy can get, tortured into somehow going with that. But I think there is this deeper question of when should we build and when should we not build? I don't think there's a single answer.
Yeah, to follow up on that, even though we're running a little close on time, I think there's lots of bad outcomes of people taking my paper too seriously, and one of them is to not build things, right? We should be building things, both because it creates, like, at a practical level, once it is easier for you to build the next thing once you have built the first thing, right? Even if it's a totally useless system that doesn't move the field an iota, you should do it, right? I built lots of things in my first VIS class that I'm not going to write up in a VIS paper because it helps build that skill set. We should evaluate the things that we build to build up that skill set, right? And because we're inherently applied fields, just being able to put things together and build as we learn is important, right? And also, a lot of us are here because we like doing it, and we should do things that we like, right? That's a non-trivial reason to do something. So to me, the question is, how do we reward that kind of building, even building that is, pitfall-y or trivially, in a way that makes it easier to sort of pour through the state of the field, pick out the interesting bits, build theory from them. So when there is a really good design study paper that we all use as models for years to come, we immediately say, aha, that's the one, as opposed to have to go through a ton of proceedings every year and memorize a lot of tortured acronyms.
And so, of course, this 30 minutes went by incredibly fast. And so I just want to ask you both one more question that maybe you could briefly answer before we switch to the panel, which is, what is it that you respect most about the other person's position that they've presented?
I guess I'll go first. So I just fundamentally can't conceive of the design study as an artifact without thinking about Tamara Munzner, right? I don't know how to teach design studies. I don't know how to conceive about them. Like the terminology I use, like she has infected my head in a very deep and useful way, right? So, I guess that's the summary, is that without Tamara Munzner, I don't know if I have a position on design studies because I don't think I know what a design study is.
Hard to follow the success as a parasite in infecting Michael's brain, but that's because now I'm thinking about medical analogies. So I'll do my best to not turn anyone into a shambling zombie. So thank you, by the way. That I think what I really appreciated the most about this paper is that it made me think, where am I taking things for granted about, of course, by God, this path is going to lead to victory. And I think you pointed out a bunch of places where, there are quagmires. I think there's quagmires in almost all research, but you got me to think about some quagmires that I think I had mostly ignored or thought that they were small. And I think some of them are large and some of them are sort of perhaps more directly across our paths. So you've got me to really think deeply about, how often really should we build? I still think, we should build a lot, but maybe the answer is we should build less. In the past, I've advocated for, maybe we should have more like pre-design papers where you just do the qualitative study and the task abstraction and you stop, no building. And what if we had more papers like that? So far, it would be very hard to get it in. Maybe what you've just argued, Michael, is you should be able to stop there and say, like, look, here's all the stuff we tried and then Excel worked better. End of story. that would let us learn something. So I would love to see a world where we had a broader set of what was accepted as papers. So you've made me think about what kind of a world that might be. Thank you.
Well, with that, I want to thank both of you so much for engaging on this, and Michael for writing a very provocative paper. We are going to transition to the panel. Unfortunately, Michael has to say goodbye because he is double booked. Tamara is going to stick around with us. And we will be taking audience questions after panel presentations. So we're going to start so that we're sort of going to extend beyond just thinking about evaluations and design studies. And we're going to instead start thinking about visualization evaluation moving into the next decade. And so we have a panel of 5 really wonderful visualization researchers. We have Aditeya Pandey, who is a PhD student at Northeastern University. And he actually is going to be doing his panel position on a paper that he wrote for BELIV, which is called Towards Identification and Mitigation of Task-Based Challenges in Comparative Visualization Studies. So he will be presenting the very first position statement. After that, we have Danielle Safir, who is a professor at the University of Colorado Boulder, followed by Florian Alt, who is a professor at the Research Institute for Cyber Defense in Munich, and then Tamara, who is going to be presenting on something slightly different than what she was talking about here, but I encourage you to also ask her questions about her positions in the Fireside Chat. And then finally, at the end, it will be Petra Isenberg, who is a research scientist at INRIA. So thank you, panelists, for taking part in this discussion. We'll start with you, Aditeya, and we will go from there.
Hi, good afternoon, everyone. I'm Aditeya Pandey, a PhD candidate at Northeastern University. And today I'm going to talk about a work that I did in collaboration with USMA and our advisor, Michelle Barkin. In this work, I'll be discussing some of the task-based challenges that we encountered during the design and analysis of comparative visualization studies. Let us imagine we live in a universe where researchers have not yet figured out what is the best way to, look at the height of a tree visualization. And in this universe, let us imagine there are 2 researchers, Holly and Amrit, who are trying to design studies. So we're trying to design studies that can actually help them identify which one of these 2 visualizations will be a better way to look at the height of the tree. However, the way Holly and Amrit report the tasks in their respective papers is a little bit different. So Holly reports the task, but in addition to the task, she also describes what was the definition of height of the tree and some additional information like how many minutes users had to complete the task. However, Amrit just reports the task as he asked in the study. Let's imagine there's another character in the story, Aditeya. He wants to study the results from these 2 amazing evaluation papers and use it in practice. However, when he looks up the task descriptions in the paper, he realizes that it's not easy to compare these 2 tasks because of the variations they have in the way they've been phrased. So I think the point that I'm trying to put across through this narrative and the story is that inconsistency in task communication can impede the process of knowledge generation. And our paper tries to explore these inconsistencies, and we call them task-based challenges of comparative studies. This work is being done from the perspective of a researcher or practitioner who's using these comparative studies for further research. So in order to understand that perspective better, let us just try to see a few goals that they might have. They might want to study these comparative evaluations to generate some kind of knowledge. They might want to solve some practical problems using the results from these studies, or just extend the knowledge by evaluating more tasks. However, the way tasks are being communicated, they could inflict some pain or problems to the researchers. Like they might not be confident about the reliability of the results. Some of the tasks, if they're not phrased correctly with abstractions, they might be hard to compare across studies. And eventually, some of these things could lead to reinventing the wheel and conducting tasks that have already, or evaluating tasks that have already been evaluated in the prior research. Therefore, in this paper, what we're trying to do is contribute a more formal set of task-based challenges with the goal that if we can define these task-based challenges, then we can think of ways to solve them. And these challenges that we are discussing here are derived from review of visualization literature and from our personal experiences. Let me start with the first challenge, insufficient justification of the task source. I saw, and when we were analyzing, a lot of studies fail to describe the source of the task, the method of the task collection, or sometimes they don't even provide an explicit rationale for selecting the tasks. For example, in this paper, we saw that the authors were just using this particular statement to justify the selection of the task. They said that the tasks were selected based on requirements of a user in data mining context, but nothing additional information was provided to help the end user or the researcher who's analyzing the study to get more sense of why these tasks were selected. We're not the first ones to realize this. In fact, in the context of evaluation, Catherine Pissant noted that the current method of task selection can be ad hoc and which can result in collection of wrong or incomplete tasks for an evaluation study. The second challenge that I want to discuss about is missing task abstractions. Task abstraction is the process of removing domain-specific terminology from the task description. And we noticed that some of the papers did not have proper abstractions of the task they were using. To give you more context about this problem, let us discuss these two tasks. The first task is about looking up hierarchy in a file system dataset, and the second task is looking up hierarchy in a geographical dataset. If you see at a high level, these tasks may look a little bit different, but if the researchers who were actually designing these studies, created an provided abstract definition of the task, it would have been easy to notice that these tasks were very similar, and the end user could have compared the results or trends from these two studies. But unfortunately, if the task abstractions are missing from the comparative evaluation, this activity of performing comparisons could become really difficult. One general problem that we noticed was comparative studies do not have a standard method to frame the tasks that are used in evaluation studies, which leads to inconsistent task descriptions. Let us just consider these two task descriptions. You can see the bolded paragraphs kind of highlight, in addition to the actual task, what was the additional information that was being provided. The task on the left was giving some instruction related to the task, and the task on the right did not give instructions related to the task, but did provide some additional information, like how many minutes were allocated to perform the task. I think consistent task description is important because, as noted by Sheila Carpendale, if visualization tasks are not defined clearly, they can be hard to test and empirically fail to provide insight into the usability of visualization technique. The last challenge that I would like to highlight here is sometimes we notice that existing comparative studies are focusing on a subset of evaluation tasks. To give an example of this, while we were surveying some of the tasks, we noticed that 4 different comparative studies were, in a different sense, trying to evaluate the same task, like how how many levels are in a tree, or what's the height or depth of a tree. Now, this is not a bad thing necessarily, because I think having more data points is good, but if the context was to evaluate novel tasks, I think we are missing a point here, and we are not able to evaluate the novel tasks. Okay, I'm sorry about this particular point. This wasn't supposed to be there, but moving forward. So since these tasks or the challenges that we've discussed were discovered from a qualitative review of literature and from our personal experiences, we thought it was important to analyze these problems in the context of evaluations or existing evaluation studies. And for that, we conducted a survey of 23 visualization evaluation papers, and we went through the task description in these papers and tried to see if we can find evidence for the challenges. In the interest of time, I'll request you to look up our paper to get more information on the detailed methodology and the results of the survey. Finally, for the panel, I think I'm going to motivate and put out my provocation and also discuss some of the ways that how we can mitigate the challenges from the context of a study designer, and how we as the visualization community can help in solving these challenges. These solutions that I'm proposing are more from a discussion perspective, and I've divided them in from the role or the perspective of a study designer and the community. I think in terms of task selection, a study designer can focus on being very explicit with the source and rationale of the task. But as a community, I think it's important that we think about the source and rationale and try to give the designer more theory or more knowledge onto to figure out or describe which, or to decide onto which particular source they should be using. For the task abstraction, I think I would like to say that researchers who are designing the study should try to perform the abstraction themselves. They should not leave the abstraction to the final user, because that could be error prone and they might want to reduce that error. But however, I think as a community, what we need to think about is some pedagogical resources that can actually help study designers to choose an appropriate task abstraction framework. I think there are many task abstraction methodologies, and all of them are great, but it would be really helpful if the designers had more resources on choosing the right framework. And I think in terms of task reporting, the designers need to go beyond tasks and also report additional information like the instruction, time constraints, and other things about it. And as a community, we should think about how could we build more formal templates to help our study designers to report these details. With that, I'd like to conclude my talk. And if you want to learn more about our paper, please visit our website or find our paper at this OSF link. Thank you.
Thank you so much, Aditeya. All right, so that is the first of our panelist positions. From here, we're going to move to Danielle. Danielle, you're muted.
All right, so, and then unmuting, of course, juggled everything around. Sorry. Let me try sharing again. All right, awesome. So thank you so much for the introduction, Miriah. So what I'm going to argue today is that visualization evaluation has really evolved to a point where it's time for us to start thinking about moving beyond conventional comparisons like A/B testing to instead try to understand and evaluate what do people actually see in a visualization. And I want to ground this in a quick example. So here are two COVID dashboards. We have our conventional style of A/B evaluation, which would simply ask which one of these two options is better. So I might run this evaluation and figure out that dashboard A gives me my information faster. So maybe we should use dashboard A. Or dashboard B lets us get more insights. So as we talked about, or as Aditeya just talked about, when we start to change this task, we're changing what better might mean. So we might find that B gives us more insights. So now we say we should use B. And one question that might start to emerge as we change and we do these comparisons and we come up with these guidelines based on this idea of what is better is why? Why is it better? How do we know what visualization we should use? The next thing you know, you're running 4,200 different experiments and you're trying to oversimplify the results of these direct comparisons to avoid actually answering the question of why. And you end up avoiding creating generalizable knowledge that could transfer across designs. This isn't necessarily something that's unique to whole system evaluations too. When we think about a lot of classical visualization evaluations, some of these seemingly basic comparisons, such as Cleveland and McGill's comparison of different encoding types, essentially are asking the same kinds of question. What is better, position or size? Cleveland and McGill showed us that we could compare 2 points effectively with position. And as a community, we've taken this often to mean we should always use position when we're representing data, even though a number of studies since Cleveland and McGill have actually shown us how things like our data distribution, our chart type of task we're using, et cetera, can all affect how useful a guideline really is. So the point that I want to raise for the panel today is essentially that VIS as a field has matured to a point where we need to stop trying to generalize from a single choose A or B type of evaluation and guideline and focus on what are people actually seeing when they look at a VIS. That is, what are the perceptual and cognitive mechanisms involved in turning data from visual information on a screen to actually active knowledge. And just to give another quick example of what I mean here, when we're thinking about this classic example of Anscombe's quartet, we know that as statistics, we see 4 identical data sets. Once we map these to visualizations, we see 4 unique structures. And we know that we get information from these representations by processing the visual pixels that occur in our plots over time, starting with our sense of sight. Then some magic happens. And then we end up with an insight. For example, an insight that we might take away here is that 2 data sets of identical statistics, but qualitatively different shapes. Well, what is actually happening in between here? I think there's an interesting, rich, and valuable space that describes how we get our sense of sight and get from that to insight. How do we change from structures and patterns to knowledge? By using evaluative studies that model the perceptual and cognitive processes between sight and insight, we can really understand how the ways we visualize data determine the knowledge that people will infer from that data. And the reason that I want to put this emphasis on the necessity of evaluating based on mechanism is that it really does provide us with more generalizable and more predictive rather than prescriptive guidelines. That is, we can start to think systematically about how the design choices we make will affect the conclusions that people draw from data. And one thing that I want to be really clear about here is that this is not just a problem for quantitative evaluation, but we can actually think about conceptual modeling as well for thinking more systematically about how our visualization design choices are going to influence the overall efficacy of our final visualization. So with that, we've seen some examples in the literature. For example, I tend to live in color science land, and we see this all the time in things like recommendations to always use dark colors to represent our light values. Well, if we're just doing comparisons of dark and light ramps, we might draw that conclusion, but turns out it falls apart when our background isn't white. If we use perceptually uniform colors, that's our general guideline. It should allow us to make equal judgments in our data. Turns out that falls apart when we actually use real visualizations. Rainbows are bad, we should never use them, except in those cases where they're actually good. So we have all these exceptions and unlesses that all add these caveats to our traditional A/B style of comparison evaluations. And it turns out that if we think more mechanistically about what's going on, there might be a lot more rich space for us to explore to make more meaningful design conclusions in practice. So just to wrap up here, the takeaway I want to raise for the future of evaluation is that we need to move beyond this basic A/B comparison. It's not just trying to figure out which is better, but why it's better. We're seeing a movement in this direction in visualization, but we should make room in the community for more fundamental understanding of design that will allow us to predict when a VIS will work and how new designs might work by understanding why people process information in different ways. To put this a little more simply, that's visualization needs to reorient to understand the fundamental mechanisms that we run into using visualizations. So with that, I'm looking forward to the discussion.
Thank you, Danielle. Okay, so building off of that passionate plea, next we're going to have Florian. And Florian, you're muted.
Right, cool. Can you hear me and can you see slides? Fantastic. All right, so thanks, Miriah, for the introduction. I feel very honored to be to have been invited to this panel. And well, here's my short position talk, which will be about how we can move evaluation from the lab to the wild. So I'd like to start with a few words about myself, mainly because my background is not in information visualization, and many of you might not know me, as well as vice versa. So my background is actually in human-computer interaction, these days with a very strong focus on usable security and privacy. I currently lead a research group at the Research Institute for Cyber Defense, which is based in Munich, Germany, and previously was a professor for HCI at LMU in Munich. So the work we are currently doing primarily focuses on how we can enhance user-centered design processes so as to better focus on privacy and security. And the second thing is we're very much looking into how we can use ubiquitous technologies, in particular such that allow us to better understand users' behavior and physiology to build novel user interfaces that are both usable and secure. I just listed some of the application areas here. Behavioral biometrics, smart homes, eye tracking, as well as AR, VR, and MR. And actually, very much of the research we are doing requires us to obtain a profound understanding of human behavior and user states. And we usually achieve this by running controlled experiments in the lab that include different types of sensing hardware, often very expensive hardware, ranging from object track systems via thermal imaging to eye tracking and other forms of physiological sensors. Now, at the same time, our research is we complement our research often by deploying prototypes in real-world settings, so in the wild, simply because we know that people in the lab often behave very differently from what they do in the real world. And we do that in different ways, for example, in the form of deployments. So what you see here is a deployment we ran a few years back in the city center of Berlin, where we deployed a large interactive display. And another way we do this is we often build apps, for example, for smartphones, that we then release in application stores. So what I can actually contribute to this panel is now some insights on challenges and pitfalls of moving research from the lab to the wild. In particular, because this is something that we have been doing extensively. And I very recently co-moderated a panel, which I admit was quite HCI focused, where we were actually discussing approaches that can be used if, for reasons such as the current COVID pandemic, it is not possible anymore, or at least very difficult to get participants into the lab. And I'll just briefly summarize the key insights from this panel here. And I hope that you challenge these ideas, and I'd like to see a discussion later on whether you believe that this is applicable to influence research, as apparently I'm not an expert there. So yeah, there is a bunch of different approaches. So assume now you cannot get your users to the lab. So one thing that you could do is you could think about building prototypes that people can experience remotely. For example, by developing them in a way such you can very easily distribute them, for example, through the World Wide Web or through application stores. Related to this, you could, instead of creating a standalone prototype, think about integrating your experiment with an app or a website. We often do that, for example, using games. And the nice thing is that as a result of this, experiments can become a more natural part of people's everyday life. And I think we're going to hear another position later on that talks about ecological validity. And this is one of the driving reasons for why we often do that, even if we could get people into the lab. Another approach I look into, in particular with my group, is how we can run evaluations using virtual reality to complement or even replace real-world studies. And then one thing we often do is that we send equipment that we need for running studies to participants. We did that with VR equipment, with eye trackers, with smartwatches, and also other technologies. Now, while those four points mainly refer to cases in which you still want to pursue your original research question, more fundamentally, you could also sort of try to appropriate the research question method to the setting to which you have access to. Or you could actually think about running evaluations without any users. For example, doing what we call analytical or computational evaluations. So to conclude, I'd like to just respond to, two questions that Miriah asked us to respond to. The first one being, what is the challenge and what needs to change? I think we might want to or need to become more flexible in the way in which we run experiments. And well, there might be a need for this to be accepted by the community. We do not know this yet because I think it's, at least in HCI, we're just at the point where we see the first papers being submitted and published that sort of reappropriate the research methods, but we'll see. And then the question is there anything you have learned about your position during the pandemic? And I think the fact that we were forced to, well, in many cases, fundamentally rethink the way in which we ran experiments led to like many interesting questions we actually have not thought before. All right, with that, I thank you for your attention. I'm looking forward to the discussion and I hand over to the next panelist. Thank you very much.
Thank you, Florian. So I think we're going to continue our move out of the lab and with our next panelist, which is Tamara.
Great, just sharing screen. Okay, can you see my screen? Okay, so now for something a little bit different, as we're all hitting various parts of this. You already heard me rant a bit before, so I'll keep this one short. And I call this looking back, looking forward, because I looked back about some things I'd said in previous beliefs and decided, do I still believe them? And the answer is only partially, in terms of what I think about the future. And so, you know, there really was this early wave where we literally didn't do any human subjects evaluation at all. There was just a few computational benchmarks and some technique papers. And then there was this first wave where we're like, hey, there's papers beyond technique papers. And there was paper types, and that really did open the door to get evaluation papers accepted from, you know, both authors being willing to submit them and reviewers being willing to accept them. And so there was this first wave, very quant. And then there was the second wave that I'll call beyond quant. And it's when there started being more qualitative evaluation, there started being more sophisticated and nuanced design studies. And something I hadn't pointed out before explicitly, but I realized it when thinking yesterday, was there really was this rise of systematic review. And I think it's notable that systematic review has really caught on in this community where meta-analysis, full-on quantitative meta-analysis has not. I don't think we have the depth of papers to pull off quant meta-analysis. You know, way back, I believe we wrote a paper about some of the issues on that. But we have been managing to use systematic review in an interesting and I think fruitful way. And I've really seen this take off in the last 10 years or so, and it's now becoming much more common, as we just saw with Aditeya's nice paper. You know, that was very much a systematic review of some papers. And now we're starting to get to the point where design studies meet systematic review, and we have systematic reviews of design studies as outputs. Michael alluded to that in his paper as being maybe, you know, only one of the reasons that design studies might eventually accrete into knowledge. You know, I still think there's others, but I think that's an important wave that's worth thinking about. And then I think we're in the middle of this sophisticated quant reevaluation. I talked about this a few years ago, that there was this, you know, the whole replication crisis has really changed the field. And what's cool looking back is, oh my God, we have pre-registration now. There's much more avoidance of questionable research practices. Typically, people are thinking more about the required experimental power instead of just being like, you know, here's my, you know, 12 people who happen to be the guys down the hall. So I think we really have gotten more sophisticated, and you know, props to folks like Danielle and others that there's been this infusion of methods from vision science, which I think of in particular has been one of the ways we as a field have gotten more sophisticated. So there's been a few of these outside forces, you know, maybe the replication crisis is coming a bit more out of psychology, and vision science really has come into play. I do have some questions about Danielle about how much does VIS have to be vision science? Might there be alternate paths to truth? You know, is a mechanism a vision science question as opposed to a VIS question? I mean, I think they can harmoniously dance together, but it could be that we can make progress as VIS people even without knowing mechanism, which is, I think, a deep and interesting question. But moving on, what I think is really cool for the future as part of this whole revised restructuring effort is paper types was there for a reason, to sort of break out of the straitjacket of techniques, but then we sort of got in the straitjacket of only a very small number of papers. And now we've got this super fine-grained way. And what's interesting when I went through and highlighted, I mean, BELIV is of course all about methodologies, but all these things that are getting talked about in BELIV, like that's half of the contribution types here, but we have this much more nuanced way of describing what we're doing in a paper where we can, hey, data abstraction is a thing in this paper, you know, and task abstraction is a thing separately from whether you deployed it in the field, separately from whether you propose theoretical guidelines, separately from, you know, are you doing qual or quant actual methodology for looking at human subjects. So I think there's a lot of possibility for the future where we'll be able to do super cool things that were hard to imagine with the former papers type straitjacket. And then, okay, so what's my wish list? What do I want to see more of? I'm hoping for this fourth wave where, just like we legitimized quantitative work and then we sort of went back and thought about how to do it in a deeper way. I'm hoping for this next wave of qualitative work where we have these deeper connections. You know, a lot of people are calling out to this, you know, a greater connection to the, you know, books like Data Feminism, you know, Joe Wood's stuff about literature design studies. You know, there's a lot of calls for connecting with the outside world more. You know, Miriah and Jason's fantastic rigor and design study paper about, you know, these different paradigms. And we're starting to see, and I hope we see more of it, abstractions is not just as a design study thing. It's a way to frame technique papers, right? It's a way to sort of build these meshes between. And I would love to see that design studies and application-driven visualization more generally stay vibrant and very much at the forefront of what's happening in the field. And I wonder about a fifth wave. Might we be able to have what I'll call true, deep, interesting, complicated mixed methods approaches where there's not just the quant people and the qual people, but those who really try to mix those methods together in a deep way. And so I look forward to seeing what that looks like in visualization in particular. I'm looking forward to seeing a lot more benchmark data sets. I think we started to see some more with data, but we, you know, Aditeya just talked about benchmarks of tasks and what does that look like? So I think, you know, even beyond task taxonomies in the Discord, people have been talking a little bit about why that's complicated. You know, do we just have yet more taxonomy papers? Are there other mechanisms for producing useful benchmarks that pertain to tasks? And then I mentioned that replication crisis. Well, we're doing pre-registration now, which is great, but we still do very few actual replications. You know, we're not freaking out that they're not getting accepted because not that many people are trying to even submit them. So I look forward to seeing a lot more of that. There've been a few, you know, there was like, you know, the Mechanical Turk replication of Cleveland and McGill, but it's by no means a normal thing. It's still quite rare. And I wonder, you know, I forgot exactly what it's called. It's not the repudiation project, but it's something where in like social psychology, people can say, I no longer believe in that past paper, which is a less extreme thing than withdrawing it. You're not saying like it's, you know, is a product of its times, but I don't believe it today. And I wonder if we would want to do such a project here now. I think the politics of that are super complicated and delicate. And what if one author wants to and the other doesn't? And does it stomp on people's careers? And what if people get mad at each other? So I don't even know how to handle that because I've thought about that with some of my own papers and I've been like, I don't want to be the first one to do that. But if a bunch of us did it, then maybe it wouldn't be quite so complicated. So that's my wish list. Really looking forward to seeing what other people think.
Thanks, Tamara. Okay, so we are going to move on to our last position statement from Petra.
Okay, so my own video. How do I turn it? So I'm going to tell you what my wish list for wave 4 looks like. Wave 5, I would agree with. Wave 4, I have a little bit of a different wish list. All right. So in the following slides, I'm going to use evaluation as a term to describe ways to judge the value of visualizations. And this term value of visualization is not something I invented. You'll see this particular paper win an award at this conference, a Test of Time award, where Jaap van Wijk argued with a technological perspective on visualization that a very important value of visualization has to do with how effective and efficient they are. And here at BELIV in 2014, John Stasko had a similar paper where he came up with he described a couple of other metrics to judge value that together I would bundle under this term of a performance-oriented view on what makes visualizations valuable. So what is the problem with that? In general, in the past couple of years, I've been getting into some research areas in VIS where I've increasingly been wondering to what extent we actually care about these performance-oriented ways of judging what makes a visualization valuable. In particular, I'm talking about things such as data physicalization, data art, personal visualization, embedded and situated visualization, and immersive analytics. And really here, the question I'm posing is to what extent in these kinds of emerging fields, areas in visualization research, do we actually care about performance metrics? And what I would like to see is us move more from understanding the performance to understanding people's experiences with these kinds of visualizations. So what needs to change in order to make that happen? So of course, HCI is a little bit ahead of us in talking about research methods and evaluation methodologies, and they've made this transition to understanding user experience coming from understanding usability, where these more performance-oriented metrics are really important. And really what I would like to see is us understanding more what the hedonic qualities of visualization are, like what makes visualizations have some characteristics such as being fun, original, engaging, interesting, cool to the audience that are using them. And of course, there are many people who've talked about this in visualization, often very dedicated to specific areas. This morning, this afternoon, Annie Bars talked about a method for actually judging experiences, which I think was great, and we need to see more of. A lot of the research on personal visualization, such as here, has argued for the need for this kind of judging, understanding experience. In regards to data physicalization, we had a visualization viewpoint that tried to address this issue and describe what we could do and what we could study instead as well. So my statement is that if we want to really understand what visualization means to people, if you want to apply them or distribute them more broadly to all sorts of audiences, we really need to understand how they react to, how they experience visualizations, and what these qualities of visualizations are that help people, or that cause people to have certain types of experiences with them. Just very briefly, Miriah asked us to add one question: what did I learn during the pandemic? About this topic, not too much. I looked a little bit at what could we do in order to replace lab studies. I found there's lots of methods to use. I started to create a reading list for my students to look into what has been published at BELIV or in other areas, in particular HCI, which relates to this question that people, I'm happy if people adding papers to that they like. That's not super related to my statement, but still something. I can post the link on Discord later. I left a lot out here. There's a lot of work done on studying experiences all over the place, even in VIS. But I'm very happy to discuss, because I think this is a super important topic moving forward as we want to bring visualizations to all sorts of audiences on new technology, new contexts, and so on.
Great, thank you, Petra. All right, so I think now we're going to move to the Q&A portion. I have to say it looks like there's a ton of discussion going on Discord, so we'll see if we can try to make some sense of questions. But there was a lot of conversation during Aditeya's presentation about task, and so I want to ask a question from Alex Kale that he asked. It's related to task, but I think applies more broadly to all of your positions, which is, he says, task variations across studies and applied settings seem like a major problem for knowledge accrual and transferability of findings in our studies. On the other hand, this variation seems inherent to the kinds of contexts that we're studying in these different modes of research. Experiments tend toward toy versions of problems and use tasks that seem ecologically valid, whereas design studies tend toward tasks that users care about in a particular setting. But isn't this exactly as it should be, despite the seeming lack of coherence in the literature? And sort of as a follow-up comment from Sheila, she says, there's many ways of gaining knowledge. Why would we turn our back on any of them? She says the answer to which is best is it depends. But anyway, so I was wondering if any of you have some thoughts on the sort of disparate nature of the different kinds of modalities that you all were talking about here, what that means for our community.
Personally, I think we shouldn't be turning our backs on any methodologies, just because they're new or they haven't been used in VIS. But I am worried about the acceptance of papers with new methodologies. And what I talked about, for example, if you're now saying, okay, we have this new visualization, this new context, we're studying how people react, what kind of experiences they were having, and people, reviewers in particular, still expecting us to do a performance-based evaluation. That's generally something I'm worried about in the community. Introducing new methods is not simple. For an experienced researcher, it's I guess a little bit easier, but with new students, it's harder to do.
Just to jump in here a little bit on this too, I think there's a bit of a false dichotomy that emerges that it has to be all one, it has to be all the other. This is where I really like Tamara's call for what about true mixed methods work, right? I think in theory, solving the problem of evaluation VIS is solving the entire continuum. It's not just living in Quantland, not just living in Qualland, but it's figuring out how does VIS work, what makes an effective design, given all of the factors that we have to consider in this. I think it's also to the point that Florian raised briefly about ecological validity, and it's thinking about the fact that this is actually a really complex space and we don't really have any solved problems. So we have opportunities for methodological innovation that I think often go overlooked. And I think thinking about the more rich space of, rather than it's a quant study, it's a qual study, and here's how I run a quant study, here's how I run a qual study, looking elsewhere for methodological inspiration and also looking internally for our own innovation to understand how do we actually assess the meaningful differences for specific design challenges and frame those investigations in a way that allow us to generalize and assess trade-offs holistically and in interrelated ways. It's not an easy task. I think we still have a lot of work ahead of us to do, but that's personally where I would love to see us go in terms of those kinds of concepts.
And so sticking to tasks for a second, I want to talk a little bit. There was, as I mentioned, a lot of exchange about task taxonomies, and a couple people were bringing up that this is something our community has spent a lot of time on, looking at taxonomies of tasks. It's something that's important, I think, both in controlled studies, but then also for the things we do in the wild. What is the current state of what we know about tasks? Are taxonomies, are they working? Or is it just we have a new task taxonomy every time we have a new problem? What does this mean over the next decade?
Let me take a crack at that one. As usual, my answer is both and it depends. And let me talk about both sides. So I think we do continue to need new task taxonomies. And we do learn new things. or rather, we do need, as we move into new domains, sometimes we generate new task abstractions, very fine-grained way. And then, do they make their way into a taxonomy? And then to what extent do we have these, bigger and bigger umbrella Uber taxonomies, and how useful is it to do that? I think we actually need work at all of those levels. And so, I think we can trickle from, a task here and a task there up through, we've got these sort of subset taxonomies. Like, do you go by data? Do you say, this is network viz tasks versus this is tabular viz tasks and this is spatial viz tasks? Or do you do it by domain, where you have like, this is biology land and this is finance land? And so, we just keep, blind man and the elephant, we hit different facets of this. At some point, we have enough to bundle together. So, I think my answer is yes, we need it all. I realize that might be answer to every single question that gets asked today is like more, but current thoughts. Thanks.
Can I add a perspective to that? I think that's a very cool question. And as a student, so my perspective is from a student's point of view. And when I think of these new taxonomies being published, I feel it's a little bit hard to keep up with them. And it could be really challenging to like learn a new method when you've already well-versed like in one of them. So one of the things that I think could be useful would be like incremental building of taxonomies, where the new taxonomies are built off of over the existing ones, because I feel like that could bridge both these gaps. That could provide for adding new specificity or whatever you want to call for tasks descriptions, but also make sure that people who have learned a particular method of classifying tasks do not really lose that advantage or lose their knowledge about that thing.
So kind of on this note, I think particularly, Aditeya, thank you for reminding us that we have a whole lot of different types of people that we are developing our research for at this point. I want to pull from something that a number of you talked about. Danielle, you talked about this magic that happens between Viz, Insight. Tamara, you were sort of questioning, maybe it's more than perception. And I think Petra, you come in with like play, engagement, fun. And then Tamara, you talked about this very deep mixed methods that maybe we move towards in the next decade. One observation is that all of you, we just covered a whole huge spectrum of types of approaches here that all require deep knowledge. What does this mean for the next generation? What does this mean for Aditeya over the next decade, becoming a Viz researcher? What are the expectations that we're going to have to move to this sort of richer understanding of how people work with visualizations?
So I have a partial thought about that. One of the things I truly love about the Viz community is that we do have such an incredibly broad tent. So, the answer is, even as we bring some methods, as we bring new methods online and we welcome papers with new methods, the old ones still get accepted. So it's not this idea that any single student has to like master every single method in the toolbox before they can start contributing and writing papers. So having new stuff can not preclude the old still being completely legitimate and interesting. And I think that also we've often had people come into Viz with different domain backgrounds. When I think about the one mixed method papers that's ever come out of my group, it's because Anna Krisan came out of a really strong methodological tradition that she was originally trained in like biostatistics and epidemiology. And they have whole classes on experimental design as part of their normal curriculum, and at a depth at which most CS classes programs don't have. And so there was this really cool paper, Evidence-Based Design and Evaluation of a Whole Genome Sequencing Clinical Report. I was so wrong. I thought it would be boring. I'm like, oh, it's not really interactive Viz. Do we really want to do this? She's like, let's try to take design study methodology and apply it to the design of a static clinical report. And it turned out to be super interesting. It was true mixed methods. Instead of doing A/B comparison of the whole thing, we broke it up into all these teeny little pieces that they actually did have useful signal on, even though like A, B, C, D, E, F comparison of the whole thing was useless, but little teeny bits was super useful. So this idea that you can benefit from what's known in other fields and integrate it carefully in. In the past, I've used the analogy of gleaning. when you try to steal methods from another field, you can't just take a bushel basket wholesale of wheat already made into a loaf of bread. No, you carefully go through the rows and you grab little pieces here and little pieces there, and you have to put a lot of effort into getting it in. And that effort is often the result, you should get a paper just for framing it in a way that our community can understand. There's a lot of value there. So we can basically draw people in from other fields to gradually increase our toolbox of methods.
Florian, I see you shaking your head a lot there.
Yeah, I think I completely agree with that. I guess that's also what sort of, speaking now from an HCI perspective, what's often happening there. And I guess the HCI community is very welcome with new methods. So we see a lot of methodology papers in Kai, which are highly valued. And occasionally this is also, like as Tamara said, integrated with within a paper that focuses on a specific, be it, I don't know, prototype or concept or whatever. And then this method is just explained there. And then, as people sort of take it up, it probably gets accepted by the community. And I think that would really be an interesting way to go with it. So sort of people are more welcoming to appreciate those new methods.
Great. So another really lively set of things that have been discussed on the Discord channel it came about with Danielle's AD testing discussion and sort of turned into discussions about replication. So a couple of comments that people had to see if anyone wants to respond. Isenberg and Matt K were saying it's hard to find an approach to compare against, and Matt saying, and including sections of here are alternatives we considered that didn't work are not always welcome in papers. And Arvin also chimed in with, we often put these alternatives in supplemental materials, even if we're forced to rip them out of the main paper. What do we do to better support replication, to better talk about, like, sort of more authentically the whole research process and what you did? And should we be promoting replication in our work and publishing it? And sort of, how do we encourage the value of that?
So I guess I can jump in briefly here, where I think this is in part a mindset thing for us as a community, that we have a very prescribed way that we think about innovation, we think about a novel contribution. And it's once we can start to establish norms that broaden this mindset that we can really have critical conversations over these key questions that keep coming up. So I think there is a lot of value that we need to think about in terms of how replications are done, and even thinking about paradigms and drawing on other fields. Right? We're not the only ones having this replication discussion. So for example, in economics, there's a whole slew of practices for replication and extension, thinking about, can you use replication as a baseline for drawing something new or for understanding a phenomena deeper, and kind of beginning a targeted research inquiry with the idea of replication in mind. So I think there are a lot of mindsets and a lot of other disciplines that we can draw on. And to the point that Tamara raised in the last question, a lot of this is also going to be an opportunity for interesting and meaningful collaborations that are mutually beneficial across fields.
I saw an interesting panel at Kai a number of years ago that said every time we try to do a replication, we end up with at least 3 new research papers. That people were like, oh, how do you get replications published? And they're like, how do we not get papers published when we try to replicate? We learned so much.
So, sort of thinking about that, what you were just saying, Danielle, this sort of mindset change. A lot of you also talked about moving away from things that I would consider probably easily quantifiable, moving to smaller ends, whether it's people's strategies for decoding a visualization, or whether it's trying to understand someone's embodiment or engagement with a visualization. And these things to me really seem to speak to more descriptive results and less things that we can put numbers to. So I'm sort of curious what people think about that, what that might mean for our community, what we might need to change in order, if these are the kinds of things that we're advocating as being important for us to take our learning or our sort of research to the next level over the next decade. What needs to happen to better support these kinds of research questions and results?
Yeah, I think that's mostly what I've been trying to argue, is that we need to, as a community, accept that there's more values than performance values. Like if we are able to describe why a visualization is viewed understood or seen in a certain way, or why it's experienced in a certain way. That helps us understand why it has value, right? In some sense. So I would push, yeah. When I was looking at Tamara's slides, where it was like wave 4, we need more rigorous qualitative studies. I was wondering if that is really true. Like, does that mean we don't have rigorous qualitative studies yet? Are most of them not rigorous? I would say there's a, but yeah, you could sure respond.
Just to clarify, I didn't mean that what we have now is not rigorous, even though I thought there was. What I think is that there are ways of being even more sophisticated than we are, having deeper connections into other fields, not claiming that what we do now isn't rigorous. In fact, I think what we do now is rigorous, but I think there's even more depth we can get from other fields in terms of frameworks. So I think in order to get published at all, qualitative research had to be pretty damn rigorous to like make it over that gate. So I feel like at the beginning, we had some really non-rigorous quant experiments that only gradually over time got reasonable. Whereas to get the first qual paper in, it had to be pretty high level.
Yeah, because I think once you've been a paper chair and you've read your share of 500 reviews or so, you've also you'll have stumbled across a bunch of comments that are not favorable in qualitative research, even though BELIV has really been on that topic, like how do we go beyond these quantitative studies since its first like the first time it happened. And it still seems to be a common belief that it's just a qualitative study. Things that I remember reading and was like so sad. But yeah, I think in terms of what needs to happen, I think we still really need this acceptance from the community. Not necessarily that we're not rigorous enough yet. There's just something deeper that needs to change in everybody's mindset. And it's a bit preaching to the choir because the people who are here are the ones who know that.
So because we're almost out of time, I want to just pose one final question in case any of you can answer it. And the question is, based upon what you've heard on this panel, do any of you plan to make any changes in your practices or any new things you think you might want to try out? And if so, what is it that's intriguing you?
Okay, I can quickly. So I found Daniel's slides very convincing in that I think often it's not necessarily that people, well, maybe it's often people don't necessarily study why something's happening, but they might have a hunch or some idea of why the results are, came out in a certain way. That's part of the discussion section often. I think this is something that I would probably put more focus on, just putting my thoughts in on why the results are turning out in a certain way, because that can help to understand how later to study if that was actually the reason why.
All right, so with that, I just want to thank all of our panelists for taking time and being part of this panel. It was really interesting. The Discord channel, it just seems to be like continual stream. So we should all go and look at it, later with a glass of wine or something. So anyway, and thank you to all the people who have tuned in. I just want to remind everyone we have one more really exciting BELIV session coming up after the break. It's going to be about design methods, and we're going to do another round of our breakout rooms, which if you took part in the first one, they were actually really, really great. It's a chance to actually feel almost like you're at the conference. So please come to the session, and we will see you all after the break. Bye, everyone.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
VIS is a visual support system for the development of visualization algorithms. It has live compilation, automatic version control, predefined interactions, and tools for visual parameter analysis. By displaying the complete history of the algorithm, users get insights into the correlation between source code changes and visual differences.
White space surfaces are a novel approach to convey depth in vessel visualizations. The core idea is to shift all additional depth cues away from geometry and to use the usually empty space between the vascular structures. This allows us to display functional parameters on the surface and supporting cues on the background. We will explain how to generate such surfaces and how to use them as a canvas to further enhance depth and shape perception.
If machine learning were like education, we would like to test what concepts our student, the model, has learned. Has it learned the concept of object rotation? Does additional text help with object recognition? We need a methodology and platform for conducting such tests. In this paper, we present a novel visual analytics tool that enables hypothesis-based evaluation of machine learned models.
We propose a new semiautomatic method that uses topological features to guide users in tracing neurons, and integrate this method within a virtual reality framework. We use the Morse-Smell complex to find a set of candidate neuron arcs. The candidate arcs are integrated into a VR neuron tracing system and exposed through a more complex guided semi-automatic tracing tool. The topological ridge graph underlying our MSC guided tool is robust against gaps in the signal.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
Visualizing class separations is used in applications such as classification and clustering. However, many dimension reduction techniques are limited due to the issues of separability and interpretability. We propose a visual analytics framework to support the exploration of nonlinear complex separation structures with the power of locally linear separations.
Pixel Clipper allows visitors to quickly and expressively extract visual clippings from visualizations and add comments to them. The clippings are useful for engaging the public with complex datasets because they are entry points into the visualization. This can be applied in a wide range of engagement experiences, such as the use of facilitated and ambient displays at public engagement events.
Confusion flow is an interactive visualization for the performance analysis of classification models. It introduces a novel temporal adaptation of the confusion matrix, which lets model developers compare the learning behavior of multiple classifiers over time. Find out more about confusion flow in our talk or in our TVCG paper.
Suppose you want to see the overcoming structure of a new project repository. Using Git client tools, GitHub Network, or Git log command, it's quite burdensome to get overview and navigate data. We presented Gizru as an interactive visual analytics system for the Git metadata to help users explore and understand the context of development history.
The classifier trained on the historical data may fail to classify the incoming data when the data distribution is changing. This phenomenon is called concept drift. To handle the concept drift, we developed the Drift VIS, a visual analytics system to help the expert understand when, where, and why the drift happens, and update the model to improve performance.
With the proliferation of AutoML systems, it's now easier than ever for non-experts to create and deploy end-to-end machine learning pipelines. These systems explore the model search space and optimize hyperparameters in order to solve a particular task. We propose Pipeline Profiler, a tool that enables the exploration and comparison of machine learning pipelines produced by multiple AutoML systems. By analyzing these pipelines, we have the opportunity to better understand how AutoML systems work and obtain insights that can be used to improve them.
We propose an interactive ensemble analysis framework that provides flexible interactive exploration of the ensemble data. Time series characteristics of data can be obtained by fast browsing time steps. The region stability heat map view shows the stability of the selected region and provides region adjustment by directly clicking.
CMED is a visual analytics framework for exploring medical image data annotations acquired from crowdsourcing. CMED can be used to visualize, classify, and filter crowdsourced clinical data based on a number of different metrics such as detection rate, logged events, and clustering of the annotations. CMED provides several interactive linked visualization components to analyze the crowd annotation results for a particular video and the associated workers.
How many clusters can you see in these images? With different visual encodings in scatter plots, our perception of cluster count changes. We developed models that consider how visual density influences cluster perception. Further, we demonstrate using a threshold plot to optimize the saliency of clusters.
In our paper, we address the problem of navigating complex multiscale and dense environments, such as these molecular models. We present a technique for browsing a model by clicking on textual labels, which we call hyperlabels. This allows the user to intuitively navigate the hierarchical organization of the model. For more details, read our paper or watch the talk.
While meetings are an essential part of everyday business life, most calendar visualizations are not designed for retrospection. We present a tool consisting of 4 coordinated views that integrate into the user's daily workflow and are designed to promote self-awareness about past scheduling decisions. We discuss the insights gained from an internal user study and from a field deployment. We also discuss how we strongly inherit from the principles of personal visual analytics despite targeting a professional environment.
Hands-on cybersecurity training represents a domain where visual analytics can significantly improve the impact of teaching process. We describe this new application domain and introduce a conceptual model that can serve as a framework for the development of analytical visualizations. Unified training lifecycle will be discussed from the perspective of different user roles.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.
Text alignment is a fundamental technique in many text-related domains. In this survey, we cover 3 text alignment scenarios: collation task, text reuse detection, and translation alignment. On the basis of those scenarios, we reviewed the existing text alignment visualization approaches and discussed their advantages and drawbacks. We finally derived design implications and shed light on related future challenges.
We demonstrate that people can use the spatial cues available in virtual reality to help them effectively remember and recall scholarly articles. We used a virtual coffee shop and asked participants to remember 4 abstracts from scientific publications, and we termed this method a virtual reality memory palace variety.
When developing a deep learning model, people typically struggle to optimize hyperparameters that affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. Hypertender helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.